Okay, in this problem, we're gonna study the effect of a translation on a circle. What happens to the image of a circle by a translation? So assume that we have the translation given by this vector 3, 2. This means that any element or any point can be moved by this vector. Okay, so this is 3, this is the vector 3, 2. So we'll see what happens when we move this circle by this translation. So we're gonna see what changes, what happens to this circle. First, we know that this circle is centered at 0, 0, and it's having radius 2. So its equation is given by x squared plus y squared equals 4. We can also do a parameterization of the circle. So given any point here that has coordinate x and y, so we can express x and y in terms of theta. In fact, so we can find that in the x is given by, so x is this part. So if you project here, you're gonna get 2 cosine theta. And you project for the y, you will get 2 sine theta, with theta being in 0 to pi. Okay, so if we square the x and we square the y, and using the Pythagorean theorem, we get back to this equation. Okay, so first, what's the image of the center? The center is given by 0, 0, 0 by this translation. So the center, so first let's write an analytic expression for this translation. So remember that if we have 2 points, m and m prime, so we say that m is being translated by u to m prime if and only if the vector m prime is u. That means if you have an m here and you apply your vector, your translation, it will take the m to the m prime, and this vector m prime would be parallel to u. Okay, so in this case we can find the analytical expression for this one. So we can write this vector if we let m have coordinate xy and m prime have coordinate x prime y prime. So we see that, and u has coordinate 3, 2. We see that m prime is given by x prime minus x, y prime minus y. This one is equal to 2, this one equal to 3, this is 2. So we have x prime is x plus 3 and y prime is y plus 2. So this is saying that the new coordinates of the x and y are given by x plus 3 and y plus 2. So for our case, the new coordinates of the origin has coordinate x and y given by 0, 0. So the origin is gonna be 0, 0, 0 plus 3, 0 plus 2, which is 3, 2. So the origin, it's gonna move here, 3, 2, 1, 2 here. So we're gonna call it O prime. Okay, now we will have to find any other points. Okay, but we know these points in the circle, so we know that they can be written as this one. So in this case, x is 2 cosine theta and y is 2 sine theta. We can plug them here, so we get for any point it's gonna be its image under this translation is gonna be cosine theta plus 3. Pardon me, I need 2 cosine theta, and y is 2 sine theta plus 2. Okay, so any point would move to this part here. So if I do this, so I'm gonna get, using this one, I'll get it like this. Yes, the same. It's the same circle. Okay, so I had to move it here. So this is the equation of the circle. So it's given by this one. So I have the radius, I have the origin, I have the points, m primes are along this circle here. Now we can check that my circle has the same radius. So what I'm gonna do is I'm gonna take the x prime to the left. So I'm gonna have x prime minus 3 equals 2 cosine theta, and y prime minus 2 is 2 sine theta. Now if I square, I get x prime minus 3 squared plus y prime minus 2 squared equals to 4 cosine theta squared plus sine theta squared. And this gives me 4. That means I get a new circle given by x prime minus 3 squared plus y prime minus 2 squared equals 4. So this is a new circle centered at here and have a radius 2. Okay, so this is 2. This proves that the image of the circle under this translation is this circle here. Okay, and that's what we needed to show.